Dear student, in this video I am going to discuss about what is meant by critical speed of the shaft or whirling speed of a shaft. Dear student, normally in actual practice, a rotating shaft carries different mountings and accessories such as gears, pulleys, etc. When the gears or pulleys are mounted on the shaft, the center of the gravity of the gears or pulley usually does not coincide with the center line of the bearing or with the axis of the shaft. So you can observe the figure A when the shaft is stationary. That means when the gear or pulleys are mounted on the shaft. So this is the shaft. Okay, the center of the gravity of these gears or pulleys usually does not coincide with the center line of the bearing or with the axis of the shaft. Okay, and you can observe in the diagram 2, that is when the shaft is rotating, right? The center of the gravity of the gear or pulley is at a certain distance from the axis of rotation. Okay, so this is the distance from the axis of the shaft. This is the axis of the shaft and axis of rotation. Okay, so the due to this the shaft is subjected to centrifugal force when the shaft rotates. So this centrifugal force bends the shaft, which will further increases the distance of the center of gravity of the gear or pulley from the axis of rotation of the shaft, and in turn it will further increases the value of centrifugal force and thereby once again increases the distance of center of gravity from the axis of rotation. Okay, so the speed at which the shaft runs, so the additional deflection of the shaft from the axis of rotation becomes infinite. So that is called uh, whirling of a speed of a shaft, right? Let us consider this is the shaft, negligible mass carrying a rotor as shown in this figure, right? The point O on the shaft axis, G is the center of gravity of the rotor. So critical speed, that is WC equal to this is not W, omega C, that is critical speed, omega C or omega N equal to square root of G divided by delta. So if it is required to calculate in terms of critical speed, so NC equal to 0.4985 divided by square root of delta. So that is in expressed in RPS, revolution per second. So for what purpose we are going to study the whirling, that means reason for whirling. Here some I would like to say about the reasons of whirling. First one, eccentricity, that means distance between the center of gravity of the gear or pulleys and the axis of rotation. The second thing, speed at which the shaft rotates. And third, bending due to its own weight in case of horizontal shaft. So I would like to discuss about what are the causes of vibration. So first one, eccentricity, that is the distance between the center of gravity of mountings and accessories and the axis of rotation of the shaft. That means when it is in misalignment, right? And second, overspeed of rotation of the shaft if the machine has imbalanced. Okay. Fourth, loose fittings of the machine parts. Okay. And fifth one is lack of wearing of components. Okay. And sixth, foundation of resonance and low torque pulsations, etc. So these are the causes of vibration. And what are the effects of vibration? So the first point is nothing but reductions of efficiency on the machinery. And second, individually stresses, that means tensile and compressive stresses in the machine element. And third one, shortening the machine life, that means machine life will be decreases. Okay. And fourth, human discomfort. Okay. And for fifth one, transverse and torsional vibrations stresses induced in the shaft. Thank you.